All right, so the question here asks us to integrate 2x plus 8 over the square root of x squared plus 8x plus 16. 16 is inside of the square root, and the second one is x plus 1 over x squared plus 8x plus 16. So I'm going to start with the first one. I'm going to start with the first one. Um, Let me start with the first one, I. So we have the integral of 2x plus 8 over the square root of x squared plus 8x plus 16 dx. So this is what we have as the question. So now how can we integrate this function? Now observe the function carefully. You are going to see that what we have at the top is the derivative of what we have inside of the square root, because if you should differentiate what you have inside of the square root, you have what you have the top. If you differentiate x squared, you have 2x. If you differentiate 8x, you have 8. Then if you differentiate 16, you have 0. So you see that the derivative of the bottom gives us the top. So what we are going to do here, we are going to let u to be equal to x squared plus 8x plus 16, so that du dx becomes, if you differentiate this, you have 2x. If you differentiate this, you have plus 8. If you differentiate 16, it gives you 0. So what is our dx? Let's find the x. From here, make the x subject of formula. You have dx to be equal to du over 2x plus 8. So this becomes our dx. So we are going to substitute everything back to the integral, so that the integral there becomes the integral of 2x plus 8 over the square root of x squared plus 8x plus 16. But you have let x squared plus 8x plus 16 to be equal to u. So in place of that, you substitute u. So what you have is the square root of u, then times dx. But your dx now becomes this. So you have du over 2x plus 8 as your dx. Your dx there becomes du over 2x plus 8. So if you observe, this now can cancel this. So if that is true, it means we are going to have the integral of what you have here is 1 over square root of u. So you have 1 over the square root of u with respect to u. So this is what we are going to integrate now, and which is much more easier for us to integrate. But we know that 1 over the square root of u is the same thing as saying we have 1 over square root of u is the same thing as saying 1 over u to the power of 1 over 2, and this, which is the same thing as saying u to the power of minus 1 over 2. So this is what we are going to have. So in place of 1 over square root u, we are going to replace it with u to the power of minus 1 over 2. Yeah. So it means that we are going to have the integral of u to the power minus 1 over 2 with respect to u. So now we are now integrating u with respect to u. And remember how to integrate. You add 1 to the power and you divide it by that power. So this becomes, if you add 1 to the power, you have 1 over 2 minus 1 over 2 plus 1. We are going to have minus 1 over 2 plus 1, and this should give us 1 over 2. So it means we are going to have u to the power of 1 over 2, then we divide it by that power, 1 over 2. Then we add a constant plus c. 1 over 2, if you evaluate this, you send 2 up. So what you are going to have here is 2u to the power of 1 over 2 plus your constant c. And this should be equal to u to the power of 1 over 2 is the same thing as square root u. So you have 2 square root u plus c. But don't forget, the initial question they gave to us was in terms of x, not u. So, but we are having our answer in terms of u. So we need to substitute back the value of u, which is x squared plus 8x plus 16, so that we are going to have 2 square roots. U now becomes x squared plus 8x plus 16, which is x squared plus 8x plus 16, then plus our constant of integration c. And this becomes the answer to that given integral. So let's refresh back what we did. This is the given question. The first thing you have to do is observe that what you have as the numerator is the derivative of the denominator. So you always let u to be equal to that denominator, which is x squared plus 8x plus 16. And you differentiate u with respect to x, so that you have 2x plus 8. Then you make the x subject of formula, because what you have here is the x. So your dx becomes du over 2x plus 8. Then you substitute back to the given question. So what you have there is the integral of 2x plus 8 over the square root of, this becomes u. Then the x becomes du over 2x plus 8. So this will cancel out. So what you have is 1 over the square root of u du. Then you can now integrate using the general formula. Then you have all this, and that becomes the solution of that given question. So let's move on to the second part of the question, which is x squared plus 1 over x squared plus 8x plus 16. Let's see how we can solve that given problem. All right, so let's move on to the second part of that question. The question asks us to integrate x plus 1 over x squared plus 8x plus 16, all with respect to x. So the first thing we have to do here is to observe again. If you see, what we have at the top is not the derivative of what we have at the numerator, because if you differentiate the numerator, you have 2x plus 8, which is not what we have at the top. So we cannot do our normal u sub here. We can't do our u sub. So what we are going to do is to reduce this into partial fraction. We know the idea of partial fraction, so I'm not going to be doing the partial fraction here, because we all know how to solve partial fraction. So you can, at your own free time, check it out and reduce this into partial fraction. So I'm going to write reducing into partial fraction. You reduce it into partial fraction. If you reduce this into partial fraction, you are going to have the integral of 1 over x plus 4 minus 3 over x plus 4 all square. The whole of this is with respect to x. So this is what we are going to have. If you decompose this into partial fraction, you have this. Because if you expand this back, if you expand this to 10, you are definitely going to obtain this back. So if we reduce this into partial fraction, this is what we are going to have. Then we can now integrate independently. So we have the integral of 1 over x plus 4 dx. Then we have minus here, we have minus 3. The integral, we can factor out 3 into 1 over x plus 4 all square with respect to x. So this is what we are going to have. I just distribute the integral. So we obtain this. So now we are going to integrate this and also integrate this. I'm going to start with this. The integral of 1 over x plus 4 dx. To integrate this, just let u be equal to x plus 4, so that du dx becomes, if you differentiate u, you have, if you differentiate x plus 4, you have 1. But if you differentiate x, you have 1. And if you differentiate 4, it's 0. From here, find the x. The x becomes du. By cross multiplying, you have the x to be equal to du. So you can now substitute back into the integral. So you have the integral of 1 over u. The x becomes du. And this is equal to, take note, If you integrate 1 over a given function, where the function is just, the power of the function is just 1, you always have the natural log of that function. So if you integrate 1 over u, you have ln u. Please take note. It follows that way. If you integrate 1 over x with respect to x, you are going to have the natural log of x. If you integrate 1 over y with respect to y, you have the natural log of y. So that is just the idea. So we know that if we integrate 1 over u with respect to u, we have the natural log of u, then plus c, which is our constant. And this should be equal to the natural log of u. We need to substitute the value of u back, and u is x plus 4. So we have x plus 4, then plus our constant c. So we are done for this given part. So let's move on to this part. So the second part, we have minus 3, the integral of 1 over x plus 4 all square. So this is what we have, x plus 4 all square. Now, we already said that we can still follow here. We said u is already x plus 4. So this is with respect to x. So we can have minus 3, the integral of 1 over x plus 4 is u. So we have u square because of this square. And our dx is already du. So we just have du here. So let's integrate 1 over u square. Because the power here is 2, we are not going to have the natural log of 2 because the power is the natural log of u because the power is 2. Had it been the power was 1, you integrate, you have ln of u. But since the power here is 2, we are going to follow the normal process. So we have the integral of 1 over u square can be written as u to the power of minus 2, then du. Then you follow your normal integration. You add 1 to the power and you divide it by that power. So if you add 1 to the power, we have minus 1. So we have u to the power of minus 2 plus 1. And we divide it by minus 2 plus 1. Then we add a constant c. And this is equal to minus 2 plus 1 is minus 1. So we have u to the power of minus 1 over minus 2 plus 1 is minus 1 plus c. And this should be equal to minus will come up. U to the power of minus 1 is the same thing as saying 1 over u. So what we have here is minus 1 over u plus c. And that becomes the solution to this part. So we are going to add this part and this part to find the complete solution of this integral. Alright, so this part we have this. So what we have there is the natural log of x plus 4. Then just forget about the constant first. Then the second part we have minus 1 over u plus c. But and then we already have 3 here. We have 3 attached to the integral. So we need to also put that 3. So what we have there is minus 3 open brackets. The whole of this integral is what we have here. Minus 1 over u plus c. So we have minus 1 over u. But we are going to put the value of u back. U is already equal to x plus 4. So we have x plus 4. You close your bracket, then you attach your constant c. So what we have here is the natural log of x plus 4 minus 3 minus 1 become plus 3 times 1 become 3 over x plus 4 plus your constant c. And that becomes the answer to that given integral. So the first thing you have to do is to reduce the integral to partial fraction. Then you now integrate independently to find the solution. So you always let u to be equal to x plus 4. Then you substitute back the value for u. You differentiate first with respect to x. You have 1. The x becomes du. Then you substitute back to your integral. You have 1 over, in place of x plus 4, you put u. Then you integrate with respect to u. And if you integrate 1 over u, you have ln u plus c. But your u is x plus 4. So you have ln x plus 4 plus c. The next one you have is minus 3, the integral of this. So I'm going to take this part. This part now, x plus 4 is already u. So what you just have is 1 over u Because this is square, so it becomes u square. The x is equal to du, so you have that. Then if you integrate this, 1 over u squared is the same thing as saying u to the power of minus 2 with respect to u. Then you add 1 to the power by integrating, and you divide it by the power, and you add your constant. So you have this. Then you substitute it back to the integral. Don't forgetting that we have minus 3 here. So you are still going to have the minus 3. And the whole of the integral is minus 1 over x plus 4. And you multiply out, you have this. Then you add your constant c, because this is a constant c. So a constant plus another constant will still give us a constant. So that's the reason why we have only one constant. Already there's a constant here, c, and there's another constant. So if you add two constants together, you still have a constant. And that becomes the solution to that given integral. So I'm going to see you in the next video on more details about calculus. So if you are new to the channel, only consider subscribing and press the like button if you enjoyed the video, and share to your friend who also want to learn how to integrate, and also comment where you don't understand. Then I'm going to explain more. To see you. Thanks.